In this chapter, we shall learn about structs in C. They are used to pack different types of data together into a single unit. In the last chapters, we learned that it is difficult to manage a large number of variables. So we came up with the concept of arrays to package contiguous units of data. But as we can see that an array can package homogeneous units only. If we have to add dissimilar items, then we need a struct. Structs have the capability to pack items of any type. They can be used to pack an int and a character. They can even hold other structs. So virtually anything, and of any complexity can be handled by a struct. This is how we can define a struct. This struct packs an int and a char together. The members of the struct are contained in these matched braces. These are the contents of this struct. A struct definition is always terminated with a semicolon. The struct definition describes the contents of a struct. It is a layout map, not the building. It's just a description. A struct definition is the layout map. It doesn't allocate memory. This program contains a struct definition. It says that the struct will contain an int and a char, but creates neither. Memory is allocated by a process called instantiation. Instantiation is done by creating an object of the struct. This statement creates an object of the struct and gives values to its members. Values to the members can be given by using the same syntax as an array. C provides a special syntax for accessing the individual members of a struct. Square brackets are not used for this purpose. This code shows how to read the values of the members. This is how we can display the value of I. Use a dot with the struct identifier to reach the data member. We can similarly use a dot with the other member to display its value. This code shows another struct with two int type of members. The members can be accessed by using the same dot notation. Here we are giving values to the members. Here we are reading and displaying the values of the two members. The dot notation is used for both reading and writing the individual members. A struct contains data, and compiler has to allocate memory for that storage. In this code, a struct is defined and instantiated. This is the object of the instantiated struct. This prints the address of the object. The address of operator gives the location of the struct. This is the output on my computer. The members of a struct are laid in the first-come first order. The member that appears first is laid first. The first member will be laid first, followed by the second member. In this code, a struct is being created and values given to its members. After that, the addresses of the members are being printed. You can verify that I is laid first and J after. The ordering is preserved.